In this presentation, we're going to take a look at the EF3 tornado that moved through the Nashville, Tennessee area late on the 2nd of March 2020 through early on the 3rd. This slide shows a tornado track, and you can see there in central Tennessee over Nashville, we've got EF3 lit up as it goes through with a couple of warnings there, and it extends on into eastern Tennessee and ends up at an EF4 over there. It was on the ground for over 60 miles in over 1 hour, and its widest point was nearly 1/2 mile wide, and it was EF3 as it came through Nashville. The system was slightly under forecast by SPC up to 24 hours out. This is the 6Z post of the day 1 categorical outlook, and as sporty as it got was merely slight in western third or so of Tennessee, and that stayed pretty consistent throughout the day. They really didn't step it up or extend it out over the Nashville area through the whole period, and you can see on the reports there, really laid it down from northeast Arkansas, kind of skipped over Memphis, and then just tore a very long path. This system did all the way in from almost across the whole state of Tennessee there. Setting up the upper air for you, we've got the 250 millibar chart, and we can see there's copious amounts of exhaust there with over 150, 160 knots of jet, and that jet max moving through Arkansas into Tennessee at that point is the left nose of that jet max. Of course, that's the most divergent quadrant, so lots of upper level exhaust present, and on out into the 12Z charts, this was pretty evident as well. Moving on down into the mid-levels, 500 millibars at 0Z indicates a highly zonal flow across the Great Plains into the Tennessee Valley there, but you can see there's a closed baroclinic low digging to the southeast over Baja from 12Z to 0Z that day, and it's kicking out numerous shortwaves to the east in that zonal flow at a pretty good clip, 50 to 70 knots or greater on the speeds, and a lot of thermal troughing to go along with it, so plenty of mid-level dynamics in place that evening as well. The low-level chart we've got here is a 925, also at 0Z, showing the Gulf of Mexico is open, and from the 2nd at 12Z there was a very strong low-level jet that morning, or greater than 45 knots. It was 50 knots or greater in place, pulling north with a good moisture plume up from the Gulf, and also significant warm air advection in place at that time as well. You got good thermal packing upstream. More low-level triggers in place. Low pressure system that's deepening over southern Illinois has got a warm front extended down into west central Tennessee, and this is at 3Z, about 3 hours prior to our event, so plenty of low-level convergence in place at the surface as well. Here we've got the 0Z Nashville upper air RAB sounding. Nothing indicative of tornadic cells at this time. This is about 6 hours prior to our event though, and the dry slot in the mid-levels there at 500 makes it pretty bursty sounding, so maybe a shot at some good severe winds there with it, although D-Cape's only 541 at the time, and Cape is fairly low, maxed out. Forecast surface Cape only 1174, and the actual value is much lower than that, so nothing real threatening at that time. On this slide we can see the short-range rapid update model data is indicating elevated numbers on the storm relative helicity. You can see a bullseye of 500 or greater in west central Tennessee starting at 4 Zulu and moving through into central Tennessee by 6Z. So those values are well over 500, and the threshold is 400 for tornadic supercell possibilities. So this should have been a red flag to step up the radar interrogation, start intense radar interrogation for any storm cells moving from the west towards Nashville at that time, and the watches would have needed to be out by 3 to 4Z. On this slide we've got a 4-panel display, base reflectivity in the top left, correlation coefficient in the top right, radial velocity bottom left, and ZDR in the bottom right. And we have approximately a 1 hour loop that starts about 40 minutes prior to the event. We can see it lands in the black circle there with the plus FC in it. That's the report. That is within 5 nautical miles of the Nashville airport, which is about 4 miles and some change off to the southeast there, KBNA. in the loop. We can see base reflectivity in the top left has one of the better signatures. We get a distinct hook echo as it's rolling in to the report area there where the plus FC is. CC and ZDR both do show a bit of a depression as it's moving through. We've got a bad spot just on the southwest side of that, the black circle for the report, where there's some beam blockage and a lot of interference there. So as it's moving through, it kind of gets swallowed up in that, and then as it moves across the report area, it gets closer to the RDA. We pick up a lot more noise, and it's a much more difficult to distinguish at that point. So it's a very short period where we have a good signature on radar that should help us pull the trigger on a tornado warning. In the bottom left-hand corner base, the radial velocity there, we do get a convergent couplet right as it's coming across where the report shows. Okay, this base reflectivity loop 0.45, but it's sales cut, so it's a little bit later in the volume scan. So about halfway through the volume scan, we're seeing a new 0.5, or lowest cut rather, of base reflectivity. And you can see this is about approximately 1/2 hour prior to the event. We've got a fairly well-developed hook echo with a massive main downdraft in it, and roof length downdraft is showing up there a little bit as well. And the loop runs through 49 after, which is a little bit after the event there over the plus FC mark, which is just to the northwest of Nashville Airport. This in combination with the mesocyclone we're going to see on the next slide, the radial velocity should be enough ammunition to issue a tornado warning with sufficient lead time. Here we're looking at the radial velocity from 0611, so 30 minutes prior to the event. And as you watch the loop, watch the top left corner, about the second frame, we'll start to see a mesocyclone enter the picture, and it keeps its coherence through pretty much the entire loop. And we'll see occasionally it'll ping some gate-to-gate shear, but mostly just a very strong meso. As long as you got a strong meso and nasty reflectivity signature like we saw on the last slide, that's good ammunition for issuing a tornado warning. You can see that couplet, that rotational couplet, it does stay coherent all the way across the plus FC spot there where the event occurred, which is less than 5 miles from Nashville Airport.